40. At time t is greater than or equal to 0, the velocity of a particle moving along the x-axis is v of t equals t squared minus cosine of t. At time t equals 0, the location of the particle is negative 5. For what value of t will the location of the particle be 0? Okay, so what we have here, first off, we have a velocity function, v of t is t squared minus cosine of t. Okay, let me write that down here. So v of t is equal to t squared minus the cosine of t. We have time t equals 0, location of the particle is negative 5, so that means that x of 0 will equal negative 5. And I should know that we're looking for the value of t that will make the location of the particle 0. I know that the displacement of the particle, okay, the change in x, that's the displacement, will equal the integral from 0 to t of my velocity. Now, I'm not going to put a t in the velocity because that's one of the limits of my integration, so I'll say of u squared minus cosine of u du. Okay? And I also know that any location, I'm actually looking for the value of t where the location is 0. I'm looking for where x of t is equal to 0. But I also know that my location at any time t will equal the location at time 0 plus my delta x, or plus the integral, the displacement here, from 0 to t of u squared minus cosine of u du. Okay? And from here, I can start to try to solve this, so let's break this down a little bit. I want to find what value of t makes x of t equal to 0. So I will replace this x of t with 0 and try to find out what this t has to be. So 0 equals x of 0 is negative 5 plus the integral from 0 to t of u squared minus the cosine of u du. And a few things. First thing, I'm going to add 5 to both sides. I think it's a little bit cleaner that way. So let's put a 5 over here equals, and let's take the antiderivative of this, which gives me u cubed over 3. Add 1 to the 2, bring it down to the denominator. And then the antiderivative of negative cosine is going to be negative sine of u. And I'm going to evaluate this from 0 to t. And that's actually really quite easy. I still have the 5 on the left, so I put in the t to both of these. I get t cubed over 3 minus sine of t. I put in the 0, but I'm not even going to write it because 0 cubed is 0. Sine of 0 is 0. 0 minus 0 is 0. Don't need it. Okay. Now, if you watched one of the earlier videos, you got the idea for this, but if you didn't, I have an equation. It involves a third power of t, and involves a sine of t. And this isn't necessarily easy to solve sort of exactly, but there's an easy way to do this numerically since I have a calculator. If I graph the left-hand side and I graph the right-hand side, what I'm going to try to see is I want to find what value of t, and I'm actually going to use x when I graph it on a calculator. What value of t makes y sub 1 equal the second graph, y2? And I'm going to do that with an intersection. So now let's go ahead and go to the graph. And let's see what we've got. Okay, so graph y1 I'm going to make equal to 5. y2 I'm going to make equal to negative sine of, and oh wait, hold on. Let me do the x cubed divided by 3. It'll do the order of operations correctly. Minus sine of x. And before I go ahead and graph this, let me just make sure. Yeah, I'm in radians. Okay, good. So let me graph these, and I want to see where they intersect. So there's 5, no surprises. And here comes my next curve. And I'm going to see that I want to know what x value makes them equal, so that's going to happen right in here. And I can get I could try to trace to it, but the calculator will do it for me. If I go to second calculate, I'm going to find the intersection, so press 5. Okay, let me go over near where they intersect. Alright, I'm on my first curve, y1 of 5. I'm on my second curve, x cubed over 3 minus sine of x. And my guess, well, that's really close to where they meet, so let me just put that as my guess. And I get 2.5541609, and I can see now that my answer is 2.55, D.